Okay, today we are going to discuss in the module 2 conics. Before we go into details, first let us know what is this solid. This is a cone. This is called a cone having a circular base, and this is called an apex. So this axis, what is meant by an axis? Axis is an imaginary line joining the apex and the center of the base. So this is called the axis, and any line joining the apex to the base, they are called as generators. So next we will see what are the conics. Conics are the different curves obtained by cutting the cone in different positions. If you see this figure, the cone is cut in different fashions. You will see if you cut parallel to the base, you get a circle that is indicated by color red, and if you cut the cone inclined to the base, you get an ellipse. This inclination, as it varies, you get parabola and hyperbola. So it is shown in this figure with the different colors. If you see here again, a double cone means there are two cones one over the other with an apex common. So if you cut again, you can see you will get a circle if you cut the base parallel to the base, and if it is cut inclined to the base, you will get ellipse, and parabola parallel to one generator, and hyperbola parallel to the axis. So from this figure, what is an axis and how these conics are obtained, one can easily understand. Now let us see first ellipse. So ellipse is a curve obtained such that the section plane cuts all the generators of the ellipse, cone. See, you can see the application of the ellipse in the practical life. See, this is a bridge where you find the shape of the curve as ellipse. Similarly, everybody must have seen the Godavari bridge. See, all these arches are elliptical shape. So you come across the application of the elliptical curves in various bridges or in the buildings architecturally they are used. Now this let us see in detail. So here in this figure you will see the section plane, this is the section plane cut parallel inclined to the base, and it cuts all the generators. Thereby you will see on the other figure, the one part is removed and you will see the section which will be like which is an ellipse. So next, parabola. How do you get a parabola? When the section plane is inclined to the axis and cutting parallel to one of the generators gives parabola. Again you will see the application of the parabola. This is everybody knows McDonald's is a very famous this one. You will see this two arches of the letter M, they are nothing but parabolas. This is how again you will see the application of the parabolic curves. So this figure tells how a cone is cut to obtain the parabola. So here the section plane is parallel to this extreme generator, and you see on the other figure the section is a parabola. Now coming to hyperbola. What is a hyperbola? When the section plane cuts a single cone, or if you take double cone on one side of the axis and parallel to the axis, gives a single or a double hyperbola. Again you will see this application of the hyperbola in the civil construction structures. See, these are all hyperbolic curves. So you will see here the section plane is parallel to the axis. This is the section plane and parallel to the axis. And when you separate the pieces, you will see the hyperbola. This is a single hyperbola because we are cutting a single cone. If you look at this double cone with a common apex, you will get a double hyperbola. Now coming to construction of these conics, whether it is ellipse, parabola or hyperbola, you can construct any of these three if you know the eccentricity. What is meant by an eccentricity? It is the ratio of the two distances. So what are those two distances? You take one fixed straight line and you take one fixed point. That fixed straight line is called the directrix and the fixed point is called the focus. So if you take the distances from any point on the conic from the focus and the distance from the directrix, the ratio is called as eccentricity. So if you see again here, the value of the eccentricity, if it is less than 1, it gives ellipse. If it is equal to 1, gives parabola, and if it is greater than 1, gives hyperbola. So depending upon the ratio of these two distances, you will get either ellipse, parabola or hyperbola. So using this eccentricity, how to construct? So this is the method. Procedure, construction is same, but the value of the E, depending upon the value of the eccentricity, you will get the corresponding conic. So for example, here I have taken eccentricity is equal to 2 by 3 and the distance between the focus and the directrix as 65 mm. So just an example I have taken. So 2 by 3 means it is less than 1, so it gives ellipse. So this is how to start. First you draw a line AB, perpendicular line, and take a point O, and at O you draw a horizontal line OD. On this you mark the distance 65 mm to get the focus F. So OF represents 65 mm. Next on that you have to locate the point V, vertex. Vertex is a point on the conic. So how to locate this vertex is very important. It depends upon the given ratio, that is 2 by 3. So divide this OF into 5 parts. Why 5? 2 by 3. You add up numerator and denominator, that will give the total number of parts which you have to divide. So here 2 plus 3, 5. So you divide OF into 5 parts. So that is how. If it is 1 by 2, you divide into 3 parts. If it is 3 by 4, you divide into 7 parts. So how many parts you have to divide this distance is depends on the value of the eccentricity. So here it is 2 by 3, so 5. Next, after dividing OF into 5 parts, how to locate this vertex? Vertex V is also a point on the conic. Therefore, 2 parts you take from the focus towards left side, or from O you take 3 parts towards right side and locate the point V. Thereby you check up whether this satisfies the ratio or not. That is VF by OV should be 2 by 3. So VF we have taken 2 parts and OV 3 parts. So it satisfies the ratio. Therefore V will lie on the conic, that is ellipse. So first, before you proceed further, whether you have located point V correctly or not, you should check up, because the rest of the procedure is same, but if the point is not located properly, instead of getting ellipse you will get hyperbola. So here at this stage you should be careful in locating the point V. Next, after fixing the point V, you erect a perpendicular at V, and with VF as radius you transfer the distance to on the vertical both upwards and downwards, you will get E. So that is nothing but two parts. Now you join that point O to E and extend both downwards and upwards. The slope of this line will be equal to 2 by 3. So that is again another stage you have to check up whether it is satisfying or not. So next, from V onwards you take number of verticals at different points, say 1, 2, 3, 4, 5. You erect perpendiculars and they will intersect the inclined lines at various points represented by dashes 1 dash, 2 dash, 3 dash, etc. So now suppose you take at 1, you take the distance 1, 1 dash as radius with F as center, you cut the vertical at 1. So you will get P1, P1 dash. These are the points on the conic, that is ellipse. Similarly, you at vertical 2, you take 2, 2 dash as radius, and with the F as center, you cut the vertical at 2, you will get again 2 more points, one at above and one below. So like that you repeat until you get the complete ellipse. So you join all the points by a smooth curve, you will get an ellipse. So this detailed procedure is explained here. So you have to follow in the same order so that you will get the ellipse properly. So these points you follow. So here again you see the note. One should be careful in marking V properly on OF, otherwise for ellipse, hyperbola or hyperbola for ellipse will be obtained. So this at this stage, as I told you, one should be careful while locating the point V. Now coming to, there are other methods, special methods for ellipse, special methods for parabola, and again special methods for hyperbola. So what are the special methods for ellipse? There are 3 methods. One is arcs of circles method, that is second one is concentric circles method, third one is oblong method. So for these 3 methods, what is the data required is you must be given major axis and minor axis. So here if major axis and minor axis are given, how to construct the ellipse by using arcs of circles method. So this arcs of circles method uses this property. As you know, you must have studied in the mathematics, the sum of the distances of any point on the ellipse from the foci is always equal to the major axis. So this is the property based on this method is adopted. So if there again I have taken the some problem where major axis is 100 mm, minor axis is 60 mm. So this using arcs of circles method, how to construct the ellipse. So various steps are given, and this figure if you see a thread is taken of length equal to the major axis, and A and B here represent the 2 foci. A and B represent 2 foci. So suppose you put 2 needles at A and B and tie this thread at these 2 ends. Next you take a pencil and then draw the figures keeping the thread tight. So the path traced by the pencil will give you the ellipse, because the length of the thread is always equal to the major axis. So sum of the distances from the foci is represented by the length of the thread. So since it is constant, the path traced will give you the ellipse. So the same thing is followed here, how we do on the drawing sheet. So first you draw AB and CD to represent major axis and minor axis, and then you locate to F1 and F2, that is foci. After locating foci F1 and F2, you take between the foci F1 and O, say minimum 3 points or 4 points. Then what is to be done? So take point 1, A1 plus 1 1b is equal to AB. So A1 plus 1b is equal to major axis. Similarly, A2 plus 2b is equal to major axis. A3 plus 3b is also equal to major axis. So we are splitting the major axis into sum of two distances. So now take A1, A2, A3 as radii with F1 and F2 as centers. You draw arcs. Next you take 1b, 2b, 3b as radii, F1 and F2 as centers. You draw arcs. The point of intersections of these two arcs will give you various points on the ellipse. So if you join by a smooth curve, you will get an ellipse. So this is by using arcs of circles method. So procedure is given. Next, ellipse by concentric circles method. Same problem has been done with so various steps are explained. If you look at this figure, so draw two circles with a major axis as diameter, minor axis as another two circles. So the two circles, concentric means having the same center. After drawing the two circles, you divide the two circles by drawing radial lines as shown. So each of these radial and diametrical lines will cut the circles, both the circles. So the outer circle is numbered as 1, 2, 3, 4, 5, 6, 7. Inner circle they are given by dashes, 1 dash, 2 dash, 3 dash. So next, after dividing the circles, please see from the outer circle you drop perpendiculars to the major axis. From the outer circle, that is major axis circle, you draw perpendiculars towards inside of towards major axis. Next, from the minor axis circle, you draw perpendiculars towards outer circle, perpendicular to the minor axis. Please be careful. You have to draw perpendicular to the major axis, perpendicular to the minor axis from the minor axis circle. So these two lines will intersect at various points P1, P2, P3, and you join a smooth curve passing through all these points, which will give you an ellipse. So here two circles, concentric circles are used to get the ellipse. So therefore this is named as concentric circles method. Next, coming to oblong method. This is another method, again using major axis and minor axis. But the speciality of this method is the angle between the major axis and minor axis need not be 90 degrees. Even if it is not 90 degrees, this method alone can be applied, but not the previous methods. So please note, this is the only method which can be adopted for parallelogram. If you want to construct an ellipse in a parallelogram, only this method, but not the previous methods, either in the rectangle or in the parallelogram. So the detailed procedure is explained by various points. Now look at this figure. So here same major axis and minor axis, but the angle between them is not 90, it is 120 degrees. So in this case only oblong method has to be adopted, not the previous two methods, arcs of circles method or concentric circles method. So what is to be done? Construct the parallelogram EFGH with the AB and CD as minor and major axis and minor axis, with the angle between them as 120. Next, you take point AO, half the major axis. You take AO and then divide this into, say, 3 parts. I have 1, 2, 3 equal parts. So number of parts is here 4, but 1, 2, 3 the numbering, and then from A to F and E you divide into the same number. If you have divided AO into 4 parts, here also 4. So number must be same, A to E and A to F. But numbering, you see, observe, you give numbering from starting from A. So towards O, towards EE and towards F. So this should be kept in mind how to give the numbering. Next, afterwards, you join first C2 1, 2, 3 on the AE, then you join D2 1, 2, 3 on the major axis and extend. They will meet the previous lines at P1, P2, P3. Similarly, you join D2 1, 2, 3 on the AF, you join C2 1, 2, 3 and extend, they will meet at another 3 points. So same procedure you adopt for the other side also, and you will get total 12 points. You join by a smooth curve, you will get an ellipse. So this is what is called an oblong method. So not only in a rectangle or in a parallelogram you can adopt this method. That is the advantage of oblong method. Coming to parabola, there are two special methods. One is the rectangle method, another is a tangent method. So rectangle method, or even you can call it a parallelogram method. So this method, as I said previously for oblong method, for parabola also this method can be adopted for parallelogram or rectangle. Here, see what is data required. You need a base AB and then axis OC. So these two things must be given, and if it is a parallelogram, what is the angle made by the axis also must be given. Otherwise, you can take it as 90 degrees. So draw first AB, locate O for midpoint, and at midpoint you draw at 75 degrees OC and mark length equal to 80. Then you complete the parallelogram by drawing AD, EB. Next, you take AO, you divide this into 3 parts, you draw parallel to the axis, 3 lines from 1 to 3 parallel to the axis. Next, you join C2, 1, 2, 3 on AD, these 3 lines will cut the parallels at P1, P2, P3. So these will be lying on the parabola, and same thing you repeat on the other side, you get 3 more points. So you join a smooth curve, draw a smooth curve passing through all these points A, P1, P2, P3, C, and B. So this is how you get the parabola using a rectangle method or a parallelogram method. So this is the various steps explained. Now coming to tangent method, the name itself tells the parabola is obtained by using the tangents. So first tangents are obtained, then you draw a parabolic curve. So that is why it is named as a tangent method. So what is the method? What is this method? Here also base will be given and axis will be given. So AB is given 100 mm and OC is given 80 mm. So what you have to do is first you have to draw an isosceles triangle, say ADB. Please note this important point. First, before you draw isosceles triangle, the height of the isosceles triangle must be twice the axis. Here axis is 80, so you must take OD as 160. Twice you take. So this one should keep it in mind. Next, after constructing ADB isosceles triangle, you divide AD and DB into say some equal number of parts, say 8. Here it is divided into 8 parts, both. Numbering, again observe numbering, how numbering has to be given. So from A it is started upwards and from D it is going downwards. So don't start from A and B, go upwards, or don't start from D, come downwards. If you go from A upwards, you come down from D towards B. Or if you start from B, you go up, come down. So this is one thing one should remember. Then afterwards, you join 1 to 1, 2 to 2, 3 to 3, 4, 4, 5, 5, 6, 6, 7, 7. They represent the tangents. And if you draw a curve touching all these tangents, you will get a curve ACB. That is the actual parabola having the required axis, that is 80 mm OC. So unless you take double you will not get the correct axis. Suppose if you take initially 80 itself, the parabola you get, it will have axis equal to 40 mm. So this is one thing one should remember. So detailed procedure is explained, and again you remember the note it is mentioned. Now coming to rectangular hyperbola, it is what is the rectangular hyperbola? The product of the distances from two axes is always constant. Suppose you take a point P. So what is the data required to construct a hyperbola between two axes at 90 degrees or less than 90 degrees? Both are shown. So the data you require is the coordinates of one particular point P. So here the coordinates are given as 20 mm and 30 mm. So first you draw two axes, unless it is mentioned, you take 90 degrees and locate the point P. Then through P you draw two parallels to the two axes, that is CD and EF. Afterwards you take between CP say 3 points, and again between P and E you take 3 points, you join O and extend them, radial lines. You just draw from O to join to 1, 2, 3 and 4, 5, 6 and extend. They will cut the parallels drawn, that is CD and EF at various points. So now from those points of intersections you draw horizontals and perpendiculars as shown. You will get the points of intersections, and if you join all these points of intersections you will get a hyperbola. So same procedure even if the angle is less than 90. So this is what is called a hyperbola. So procedure is explained here in detailed procedure. Thank you.